Hello, I want to go over a homework problem from section 7.1. We're looking at testing goodness of fit for a single categorical variable using the chi-square statistic and distribution. So I'm going to look at question 7.9 from the Lock 5 textbook, second edition. And we want to know, figure out how to do expected counts, contribution to the sum of the chi-squared statistic, and degrees of freedom. So we have some observed data. So we're given observed data here. Category A has 40, B has 36, C has 49, D has 35, a total of 160. Now the expected count for category B, we're assuming with this null hypothesis that all these categories should be the same, should be about a quarter. So wouldn't be too hard to do this by hand. We just need to take a quarter of the total. Quarter of 160 is going to be 40. So there should have been 40 in category B, but there's 36. So it's off from the assumed null hypothesis distribution. The question is, how far off is it? But I wanted to go over this in a video to show you how to use a StatKey to answer these questions and to enter in this data. So I'm going to go to StatKey and look at the very bottom row, more advanced randomization tests. And we're looking for chi-square goodness of fit. So I'm going to click that. We have some pre-packaged data here. What I want to do is enter in this data, enter the observed data into StatKey. So I'm going to click Edit Data, and we're given rock, paper, scissors. I don't want that. We have category A, and that value I believe was 40. Category B was 36. Category C, going back, is 49. And category D is 35. So I've entered in the data into StatKey. I'm going to click OK. Double check. I got 40, 36, 49, 35. 36. All right, make sure the data matches up. And again, this is the original sample or the observed data right here. And I'm going to click on Show Details right here. And this gives, let's make this a little bit bigger, gives the count, observed count. That's what you enter. It computes the expected count. And notice the expected count for all of these in green is 40, because that comes from the null hypothesis. We're assuming all these variables are equal. And the contribution to chi-square, the statistic, is computed below right here. So for B, it'd be 0.4. One other thing you want to check, I forgot to do this, but click on the null hypothesis button. And automatically, since I had 4 variables, it's automatically going to make these equal. So if there were 5 categorical variables, it would be 0.2. But make sure to read the problem carefully. The goodness of fit, we could actually make these all different values if we wanted to. But in this example, we're assuming that they should all be equal to 0.25. So make sure the null hypothesis matches up with the null hypothesis in StatKey to click OK. Oh, and the degrees of freedom. Lastly, degrees of freedom is just 1 minus the total number of categories. There's 4 categories, so there's 3 degrees of freedom. Excuse me. Show you the worked out solution. Since the total sample is 160, I mentioned this, and the hypothesized proportion for B is 25%. We could just multiply those two, 160 times 25% to get 40. The formula to get your chi-squared contribution is your observed minus expected, 36 minus 40. Square that, because we don't care whether it's above or below. We just want the difference between observed and expected, and then divide it by expected to get 0.4. And that would be the chi-squared distribution.